Solve each equation for x algebraically. Justify the solution set. So we're at the point in the unit where we switch gears from solving rational equations, the one with fractions, to solving radical equations, where we're going to have square roots in our equation. And it's a simple process where we use this idea of inverse operations of, I want to get that variable by itself, so I'm going to have to undo things. So our first step is to always isolate the radical. Right now it's being multiplied by 2, so I'm going to divide by 2 to get the square root of x plus 3 equals 3. Well, how do I undo a square root? Well, to undo a square root, I'm going to square both sides. The square root and the square leave me with x plus 3 equals 9, which means subtract 3, and I get x equals 6. So just like rational equations where we got extraneous solutions, we can also get extraneous solutions from radical equations. And we need to be careful of that because it's not as obvious. We always have to take this and plug it back in. 2 square roots of 6 plus 3. Does that equal 6? Well, 2 radical 9 equals 6. Does 2 times 3 equal 6? It does. X equals 6 is actually a solution. It's not extraneous. It is a solution. This next one here, 5 minus 3 square roots of 4 minus x equals 2. Well, I want to isolate that square root somehow. Well, the first thing I'm going to do is get rid of that minus 5. So I'm going to subtract 5 from both sides and get negative 3 square roots of 4 minus x equals negative 3. Well, it's being multiplied by negative 3, so I'm going to divide by negative 3 to get the square root of 4 minus x equals 1. Now that I've isolated my square root, I can square both sides. And I'm left with 4 minus x equals 1. If I add x and subtract 1, I get 3 equals x. I'm not done yet because I have to go check that I didn't get an extraneous solution here. 5 minus 3 square roots of 4 minus 3, what does that equal? Does that equal 2? Well, that's 5 minus 3 square roots of 1, which is 5 minus 3 times 1, which is 2, equals 2. It does check out, so x equals 3 is our solution. The square root of x squared plus 9 equals 5. So the square root's already isolated, so all I have to do here is square both sides. And I get x squared plus 9 equals 25. Well, this is a quadratic equation because I've got that x squared term, so I'm going to subtract 25 to set it equal to 0, so I can apply the zero product property. X squared minus 16, that's the difference of perfect squares. X plus 4, x minus 4 equals 0, so I get x equals 4, x equals negative 4. Now, I need to check both of these solutions. I need to check both of them, so we check them one at a time. So let's plug in a 4. 4 squared is 16 plus 9. The square root of 25 equals 5. That checks out, so that's a solution. Negative 4 squared plus 9, what does that equal? Does that equal 5? Well, any negative number squared is going to give me a positive number, so I get this 16 again. So that does check out. They are both solutions. So 4 and negative 4, so you might write that as x equals plus or minus 4, is a solution to this equation. X equals the square root of 56 minus x. Well, the square root's already isolated, so let's square both sides. I get x squared equals 56 minus x. But this is a quadratic equation, so I should set it equal to 0. I like positive x squared terms when I factor, so I'm going to move these two quantities over and get 0 on the right-hand side and x squared plus x minus 56. Well, this is a trinomial. It's a quadratic and it's a trinomial, so I have to ask myself two questions. I have to say, self, what multiplies to negative 56 that adds to positive 1? What multiplies to negative 56 that adds to 1? So they're one apart from each other. It's 8 and 7, but the 8 has to be positive because I want a positive 1. I don't have to go through the whole AC method because my leading coefficient's 1, so I get x plus 8, x minus 7, equals 0, and applying the ZPP, we get x equals negative 8 and x equals 7. Those could be my solutions, but we have to go check them. Always remember to check your solutions. Does negative 8 equal the square root of 56 minus negative 8. I'm plugging them in one at a time. So, does negative 8 equal the square root of 64? No, because negative 8 does not equal 8. So negative 8 we reject. It's an extraneous solution. What does that mean? It means it solves this quadratic equation we got here, but it doesn't actually solve the original radical equation, because squaring both sides of an equation isn't actually a legal move to do. When we square both sides, we do preserve the solution set, but we also have the ability to add in extra solutions like we just did in here. So we keep the solution set the same, but we do add in the possibility that we might be adding in extra solutions. Let's check 7 now. Does 7 equal the square root of 56 minus 7? Does 7 equal the square root of 49? It does. So x equals 7 is actually our only solution here. Two more. The cube root of 5x minus 3 plus 8 equals 6. Well, I've got a cube root here. So I'm still going to isolate the radical. First, I'm going to subtract the 8. And I get the cube root of 5x minus 3 equals negative 2. If I cube both sides to get rid of that cube root, to undo a cube, I'm going to raise both sides to the third power and get 5x minus 3 equals negative 2 cubed is negative 8. Plus 3 plus 3. I get 5x equals negative 5, so x equals negative 1. We should go back and check it, but technically you don't need to check cube root equations, but it doesn't hurt to check. I always want you checking whenever you see a radical, just because you never know. You never know what's coming your way. So 5 minus 1, so that's negative 5 minus 3, that's negative 8. The cube root of negative 8 plus 8 equals 6. Well, what number times itself 3 times gives me negative 8? It's okay to have a negative inside of a cube root. If this was a square root, we'd have to call it quits here. But because it's a cube root, it's okay. Negative 2 times negative 2 is 4, times negative 2 is negative 8. So the cube root of negative 8 is negative 2. Plus 8 equals 6. 6 does equal 6. So x equals negative 1 is a solution. And finally, isolate the radical. So I'm going to subtract 9 from both sides and get the square root of x plus 5 equals negative 9. Now, maybe you did keep solving, which is totally okay, and you would get x equals 76. You would get x equals 76. But here's the thing. I have a square root equal to a negative number. Square roots never equal negative numbers. If I input any number into a square root, it is never going to output a negative number. So at this point right here, because I'm working with square roots, I know there are no solutions. I know there are no solutions to this equation because I have a square root set equal to a negative number.